can be described as a function of time. As time increases, your position changes by an amount equal to velocity times elapsed time. Your xf variable represents your final position. The variable xi represents your initial position, the variable v represents velocity, and the variable t represents time.
Lindsay travels on a scooter for 10 seconds. In 10 seconds, she goes from 0 meters to a final position of 10 meters. What is her velocity? You can rearrange the motion equation with algebra by setting velocity equal to the change in position divided by time. Therefore, velocity is 1 meter per second.
Anastasia is taking a break on her scooter while Rachel passes her at 1 meter per second. What does this graph look like?
Anastasia does not move, therefore she has a zero velocity. This is indicated by a straight horizontal line on the graph. Rachel moves with a velocity of 1 meter per second, so her graph is a linear diagonal line going in the positive direction.
Meredith and Ashley are having a scooter race. Meredith travels right at 1 meter per second. Ashley travels in the leftward direction at 1 meter per second. They start 10 meters apart and cross paths at 5 meters. At what time did they cross paths? Assume right is the positive direction. Make a graph to help. Meredith is traveling in the positive direction. Ashley is traveling in the negative direction. The blue circle is where they cross paths.
Because Meredith moves in the positive direction, her velocity is 1 meter per second. Her initial position is 0 meters, and because they cross paths at 5 meters, that will be her final position. We rearrange the motion equation to set it equal to time. Your final position minus your initial position over velocity is equal to your time. In this case, we'll do 5 minus 0 over 1, giving us a time of 5 seconds. We set up Ashley's problem the same way, but because she's moving in the negative direction, her velocity is negative 1 meter per second. She starts at a position of 10 meters, and her final position is 5 meters. So we set up 5 minus 10 over negative 1. This gives us another time of 5 seconds, indicating that they cross paths after 5 seconds.
You are riding in the red car on a straight stretch of a 2-lane highway with a speed of 26 meters per second. At a certain time, which we will choose to be t equals 0, you notice a green car moving towards you in the other lane. The green car has a speed of 31 meters per second and is 420 meters away at time equals 0.
To solve this problem, you first set the position-time equation of the red car equal to the position-time equation of the green car. You then add 31 meters per second times time on both sides to get 57 meters per second times time equal to 420 meters. Next, you'll divide 57 meters per second on both sides to get a time of 7.4 seconds, which is the time that the two cars will pass one another on the highway.
This graph represents the problem. The blue line represents the red car, and the green line represents the green car. This is indicated by their starting positions, with the green car starting at 420 meters and the red car starting at 0 meters. The red circle on the graph indicates the point of intersection. This shows the time at which they cross paths. In this graph, the time is 7.4 seconds. The graph overall shows the velocity, time, and positions of both vehicles.